Okay, so this is just a review of the last little bit of what we've talked about with inverse trig functions. You can see in the notes, I've provided the notes on the domain and range and the unit circle, so we can refer to that. And here are 16 exercises reviewing all the various topics. I'll, of course, be doing the evens. Odds will be your assignment. The first 4 involve doing a trig function of an inverse trig function. Those always involve starting with a triangle. So draw a triangle for each one of these. Oops. Indicate an angle. And in number 2, we're given the inverse cosine. Cosine, as you know, is adjacent over hypotenuse. So the adjacent side here is 3, the hypotenuse is 7, and we are trying to find the cotangent of this angle. Cotangent, as you may remember, is adjacent over opposite. So the opposite side here is something that we need to figure out. We can use a Pythagorean theorem. 7 squared equals 3 squared plus opposite squared, or you can use a variable there. It really doesn't matter. So this is 49 equals 9 plus opposite squared. Subtract the 9 over, you get 40 equals opposite squared. So the opposite then is going to be the square root of 40. 40 is not a square number, but you can simplify it. It breaks down into 4 times 10. And when you square root that, you get 2 radical 10. So we're trying to take this, which the opposite now we know is 2 radical 10, and make this ratio out of it. I didn't give myself a ton of room to do this. Let's move this a little bit. And then move this a little bit. Okay, so adjacent over opposite is going to be 3 over 2 radical 10. You know you cannot have a square root on the bottom of a fraction, so we rationalize the denominator. 3 radical 10 over 2 times 10, or 3 radical 10 over 20. And I'm going to scroll down and double check answer 2. 3 radical 10 over 20, so yes, we did it right. Number 4, in a lot of ways, very similar to number 2. So here's my triangle. We're again given cosine, which is adjacent over hypotenuse. So square root of 17 here, 17 there. This time we're trying to find the tangent of theta, which is opposite over adjacent. So once again, the opposite is unknown. I'll come off to the side here and do the Pythagorean theorem. 17 squared equals the square root of 17 squared plus opposite squared. 17 squared is 289. 17 squared is, or radical 17 squared is 17 plus opposite squared. If I subtract the 17 over, let's see, I get 272 equals opposite squared. 272 seems like a weird number. Dabble around with a calculator a little bit, you'll find out that it's 16 times 17. So when you are square rooting this, it turns into 4 radical 17. So our opposite is 4 radical 17. So now we can create an answer out of this, opposite over adjacent, 4 radical 17 over radical 17, and those 17s just cancel, and we end up with 4. So the answer to number 4 is 4. So let me scroll down and double check, and there it is. Of course, pause, go back, relook at anything if I'm going too fast. If you have any questions, you can email me or post them in the group. Okay, number 6, the inverse cosine of 1/2. This is where we're going to use the unit circle. We know that cosine is simply an x value on the unit circle, so we're trying to find an x value that equals 1/2. If I go to the unit circle, that happens twice. Once right here, once right here. If I consult my notes for cosine, the answer has to be between 0 and 180. 60 degrees, not 300, is between 0 and 180. So my answer is 60 degrees or pi over 3. And if I recall, these answers are always in radians, so I'll just go ahead and write down pi over 3. Quick double check. Number 6, yes, pi over 3. Number 8, tangent inverse of square root of 3. Tangent, you know, is y over x, so we need to think of this as a fraction, square root of 3 over 1. So we're trying to find a point on the unit circle that when you divide them, it simplifies to square root of 3 over 1. So let's go up to the unit circle, erase the notes from the previous problem. Actually, I want to go up to the range notes. I'm looking for an angle that's going to be between negative 90 and positive 90. So I have to be in these two quadrants. Now my tangent inverse of square root of 3, this square root of 3 is positive. So if I want to take y divided by x and get a positive number, I cannot have any of these points because one's negative, one's positive. So the only way to get a positive is to actually be in this first quadrant. And I'm not going to use this point or this point, 0 divided by 1, 1 divided by 0, that doesn't help. I'm not going to use this point. Square root of 2 over 2 divided by square root of 2 over 2 is 1. So it seems kind of natural that I have to have a square root of 3 somewhere in the mix. So it's either going to be a 30 degree or a 60 degree angle. Let's look at this 30 degree angle right here. Y divided by x is going to give me 1/2 over square root of 3 over 2. That cancels out. That gives me 1 over square root of 3. That is not what I want. So let's go back and look at the 60 degree. Y over x, square root of 3 over 2 over 1/2. Those cancel. I get square root of 3 over 1, or just square root of 3. So it is the 60 degree angle, or pi over 3. And look at that, it just happens to be the same answer as the previous problem we did. Let me scroll down and check number 8. Yes, right there. So there's that one. You're going to work out 5 and 7 essentially the same way. Number 10 through 12. Now we are doing inverse functions of trig functions. So they're kind of like 1 through 4, but they're backwards, and drawing a triangle is not going to help. We're going to, well, sort of do order of operations. Let's do what's in parentheses first. So sine of negative pi over 2. Go up to the unit circle. Negative pi, let me erase these notes, these little scribbles. Sine of negative pi over 2. Negative pi over 2 is right here. Sine, of course, is a y value. So what's in parentheses here works out to be negative 1. Now we're supposed to do the inverse cosine of negative 1. Cosine, of course, is an x value, so we're essentially looking for an x value that equals negative 1 on the unit circle. That only happens in one place, right here. So 180 degrees or pi radians. So the answer to number 10 is going to be pi radians. Let me scroll down and check number 10, and we see there pi radians. Number 11, cotangent pi over 4. Cotangent, remember, is x divided by y. So I'm going to go to the angle pi over 4 and divide the x and the y. Erase all this. Okay, pi over 4 is right here. X divided by y. Anytime you divide something by itself, you get 1. So, where are we? Here. This is square root of 2 over 2 divided square root of 2 over 2, which is 1. Now we're doing the inverse cosine of 1 kind of similar to the previous problem, but that one was -1. So where does the inverse cosine of 1, we're looking for an x value that's 1, that's right here. So that's going to be 0 radians. Let me go down and check number 12. 0. Brilliant. Okay. Finally, we get to the last section here. We're doing a trig function of an inverse trig function. So this is very much like 1 through 4. We're going to draw triangles, but we get to deal with x instead of actual numbers. So draw a right triangle. Pretend that's a right triangle. Good enough. Sine is opposite over hypotenuse. So x, think of as x over 1. The opposite is x, the hypotenuse is 1. Cosecant of theta is hypotenuse over opposite. So with this one, we don't even really have to do the Pythagorean theorem. The adjacent in this problem is irrelevant. It never comes into play. So hypotenuse over opposite is 1 over x. And if I go down and check number 14, that should just be the answer, yes. Number 16, maybe it'd be a little more of a rigorous problem where we have to do a little more work. So here's my right triangle. So we start with inverse cosine of x, or think of it as x over 1. That's adjacent over hypotenuse. So the hypotenuse is 1, the adjacent is x. Now we're trying to figure out cotangent. Cotangent is defined as adjacent over opposite. So in this problem, we really do need the opposite. We find that by doing the the Pythagorean theorem. 1 squared equals x squared plus opposite squared. 1 squared is just 1. I can subtract the x squared over to the other side. And then that means the opposite is going to be the square root of 1 minus x squared. So this is square root 1 minus x squared. And really we can finish the problem now. Cotangent is adjacent, which is x, over opposite, square root of 1 minus x squared. And that is number 16. Scroll down and check it. X over 1 minus x squared, and we're good. Okay, so those are all the notes. Read the instructions to see, well, I guess you know your assignment is the odds. So finish that and submit it. Thanks. Have a great day, guys.